Welcome to ClickMyProject.com. Our project title is Energy Efficient Clustering Scheme for Prolonging the Lifetime of Wireless Sensor Network with Isolated Nodes. Abstract. Energy efficiency is a most important constraint in wireless sensor network. In a large area network, it is impossible to each node send the data to sync. It takes more time and hops for transmission and lead to collision. Each sensor node has its sensing requires the capabilities of sensing, computations, and wireless communications. The power consumption of wireless communication between two nodes is based on the transition distance, which has an exponential increment with the distance. Therefore, the routes of the data transmission to the sink will affect the energy consumption. For achieving the network lifetime in wireless sensor network, we propose new regional aware energy efficient clustering method. Let us see the flow of our project. First, network is formed, then regional partitioning is done based on the XY coordination values. Then we elect the CH node based upon the residual energy. The node which have the highest energy is taken as CH node, and the information is transformed from source to destination. If the data from source is normal node, it sends the data via the CH node. If false, we have to mitigate the isolated nodes and then transmit the information. Performance evaluation is done in 4 ways. First one for throughput, second one for delay, packet delivery ratio, and energy. Let us see the output of our project. First, open the terminal window and type gedit space delta symbol /.bashrc for path setting. So we have to set this place existing have 2.28, so we have to change that version as 2.34 and change the NAM window version as 1.14 and save that and close. Then go to cd space ns 2.34 cd space ns 2.34 and type make for configuring the nodes, configuring the TCL with C++. So it produce none of the error is produced. So now we have to run the project. Open the terminal window, go to the coding folder, cd space code, then type syntax for running the TCL file is ns space main.tcl. It produce updated energy and the position of each nodes. Updated energy is nothing but the residual energy. What are the energy is available in for each nodes at each time. So our project is Readme protocol implementation. So we have to identify the energy as well as distance for creating the cluster head. So now NAM file is open. This window is called the NAM window. When we click on play forward button and increase the speed, our network is formed. Then region is split depending upon the coordination value. We take 600 cross 600 meter transmission range. In that we have to split that region as four regions. So in each region we have to identify the cluster head. The node which have the highest energy is taken as cluster head for each region. So in this region, 11 node 11 is taken as cluster head, and this 6 in this 23 and this 28 is taken as cluster head. So now the node 39 is want to send the information to another node, means it sends the information via the cluster head. The cluster head get the information from that node 39 and forward it to what it wants. So when we click on this round circle, it denotes what are all done in this process. That is, now CTS process is done. CTS is nothing but a clear to send, and when we click on that data, it shows the TCP connection and how many bytes are sent and when it's sent. So this circle for transmission range, it tells about the transmission range. So the source is 39 and the destination is the node 13 is act as a destination. So if the 39 node is want to send the information, means it's sent via the cluster head, then the cluster heads get the information and send the packet to another cluster head which is in destination, which the destination is in that cluster. Parallelly, we send more than one data to many number of nodes. The graph is generated when we type GNU plot space energy dot plot. It will produce one graph that tells about what are all done in our process and existing system, proposed system comparison. So we measured energy by joule. So joule versus number of nodes is compared with that graph. Our out.tr process is stored in this out.tr file contains our Readme protocol implementation. When we open this, we have that Readme. So in that we see that Readme. So our process is fully done on using that Readme protocol.